In Chapter 4, when we were talking about geometry, we were using two-dimensional shapes and we were finding area and things like that. Now in Chapter 8, we're going to be working with three-dimensional, or sometimes we call that 3D, figures. So we'll be naming them, we'll be talking about the different parts of the 3D figures, and then we'll be working with, as the chapter goes on, we'll be working with area and volume for those three-dimensional figures. A solid is a 3D figure that encloses a space, and we're going to be talking about that word solid quite a bit in this section. You don't have to write the definition for polyhedron. I'm just going to put it on the screen so that in case it comes up again you will have heard it. But a polyhedron is a solid whose faces are all polygons. Remember, polygons have to be closed figures. They have to have certain numbers of sides, and so if a polyhedron is a solid, it's got to have all polygons for its faces, which we'll be talking about in a minute too. There are some important parts of a 3D object that you're going to need to get to know, and one of those is called the face. And in here I've kind of shaded that in red, and really, truly, when you look at three-dimensional objects, you're going to want to know that these solid lines represent things that you can see, and these dotted lines represent things that wouldn't be seen if it were truly solid and you couldn't look through it with your x-ray vision. So these things back here would be kind of off to the side and on the back. And if you can kind of picture this being an actual box, like a shoebox or something, then this top part would be considered a face, but so would the front, so would the side, so would that back edge back there, the other side, and the bottom. All of those would be called faces because by definition here it says a face is a flat surface of a 3D object. This blue line down here is called an edge, and an edge is a line segment where two faces touch or intersect. And again, this would be considered an edge, this would be considered an edge. Any of these things where two faces, so in this case this front and this bottom face kind of intersect or touch each other, so that's why it's called an edge. But again, there are going to be lots of edges in three-dimensional objects. And finally, we have a vertex here, and a vertex is a point, kind of like when we studied angles. It was the point that happens when two lines come together and meet. In a 3D figure, it's where three or more edges meet. So back here, we've got this edge, and this edge that all come together, and that makes a vertex. And again, it's more imaginary than a big dot because there's actually a vertex up here because you have three edges that meet here, so this would be considered a vertex. We tend to call them corners in everyday world, but truly according to geometry this would be called a vertex. But when you're talking about a vertex, know that you're looking for corners, basically, is the best way to start looking for them. For example 1, we're going to be finding the number of faces, edges, and vertices. That's this word, and that's plural for vertex. I have no doubt that you guys are better artists than I am, so this is always a tough section for me because I have to try to do the best I can to draw these three-dimensional figures. So this first one in particular, I'm going to kind of step by step through it, and then you draw it the best you can. And again, I'm sure most of you will do better, and maybe even could explain it better than I can. So we'll help each other out. So we're going to be drawing a figure. So the first thing you need are two parallel lines, kind of a little bit distance but equal in height as best you can, and don't get out rulers. It doesn't have to be perfect. And then off to the two sides of that, we're going to move up a little ways from each side, and we're going to make two more parallel lines. So something like this, and about, again, equal distance as much as possible without doing big measuring. So you have two sets of lines that look like that, and then we're just going to connect these outside lines here and here and over there, and we're also going to connect them at the top front and the bottom front, and finally along the back right there. And then we're going to add in only one hidden line right now, and that's going to connect these two sections back there, and that is our 3D shape right now. And we're going to be working on finding and naming how many faces, how many edges, and how many vertices this shape has. So starting with faces, we're going to see, again, by definition, those have to be the flat surfaces. So this would be considered a face up here. You don't have to color them in, but just to kind of count along. And then we would have a face on the bottom as well. Okay, so those are two altogether. Then we have the front and back faces. So I'll switch to a different color just to kind of show them to you. So that is a face up on the front. And then you've got another face in the back. all the way back there, and I know it's a little hard to picture because they're kind of layered on there, but that's 4 faces total now. And then we have on those edges, we have 2 more faces, so 1 here, so 5, and another face for a total of 6 faces. So you could go ahead and just write in next to that shape that there are 6 faces, and again, you just kind of have to know where they all came from. Next, we need to know how many edges there are, so we're going to again look for line segments where the 2 faces meet or touch. So this is one face, or one edge where you can see these 2 faces touch, and then we have another edge over here. So there are 2 edges so far. This is an edge, this is an edge, so we're at 4 now. But then we also have faces that meet here, so that's 5 and 6. Then there are edges down here, 7 and 8. We have faces that touch on the front and the bottom, so that would be 9. And then we also have the front and the top, that would be 10. And then we have that back edge along the top and the back, and another back edge along the back and the bottom. So that is a total of 12 different edges, and you don't have to again color in or draw them every single time. You can just count them once you're looking at the 3D object. And for some reason I cannot get that one little blue line to go away, so we're not going to worry about it, but we are going to focus on vertices, which we said, remember, are basically corners, and they're a place where 3 faces come together. So we've got one up there, one there. This would be the 3rd and the 4th corner, or where all the faces meet. Then we've got a vertex over there, here, up front, and then back there. So if you were to do a quick count, we've got a total of 1, 2, 3, 4, 5, 6, 7, 8 vertices all together. And that's how we count faces, edges, and vertices. Two important shapes that we're going to be talking about in this chapter are prisms and pyramids. And when we talk about prisms here, obviously they're 3D shapes, and by definition they're going to have 2 parallel and identical bases. And if you look down here, the bases are going to be opposite each other. They won't necessarily always be on the ends because we know the shapes can be turned around, but they'll have to be 2 identical ones, and they have to be opposite of each other. And then the prism will have faces that are parallelograms or rectangles. In this case, this shape is called a triangular prism, and it has 3 faces that are all rectangles. They go kind of all the way around here, you can see, and a lot of times the number of faces will be based on, or will be determined by what the shape of the bases are. This is an important note right down here that tells you that the shape of the base is what helps us to name prisms and pyramids. So in this one it's called a triangular prism. It's a prism because it has the rectangular faces, and it's a triangular prism because it's got these triangles as bases. And as the chapter goes on, we'll practice naming these. The other one we're going to talk about is a pyramid, and again, it's a 3D figure, but a pyramid is only going to have 1 base down here, and the faces of pyramids are always going to be triangles. So again, you can kind of look over here at this example shape, and you can see all the triangles that come to a point up here. That's how you're going to know it's a pyramid, because these faces are all triangles along the edges, and again, it could get tipped, but not as likely on a pyramid. And then the name again, which you don't have to write this down a second time, you just wrote it on the last slide, but the name again is going to be determined by what the base shape is, and the polygon on this one is a rectangle, so we would call this a rectangular pyramid because its rectangle is a base and all of the faces are triangles. For examples 2 and 3, we're going to do it a little bit differently. I'm going to ask you to please go to page 357 in big green, and follow the step-by-step directions for example 2 to complete the drawing of the rectangular prism and the triangular pyramid, because the book actually takes you through step-by-step directions. And please keep in mind when you do this that I'm not asking it to be perfect, so you don't necessarily have to measure everything. The dot paper that's going to be available will make your life a lot easier when it comes to trying to keep things pretty even, but we're not judging you on drawing. You have to get them mostly accurate in terms of being able to recognize the shapes, but we're not looking for perfection here. And then for example 3, they're asking you to look at an eraser and to draw it from the different angles, front, side, and top views. And again, copy and label directly from example 3 on page 357. So that you can see the difference between what the top view looks like, the side view, and the front view. And all of this 8.1 section is actually setting us up for 8.2 and 8.3. We're going to need to be able to use all those different angles and views. So just get them copied into your notebook, and again, use the dot paper that's available for you to help yourselves out with some of these drawings.